Hello, this is Team Teach 1, Module 1, Chapter 1, Thinking Critically, and I am Laquila Dominique Roberts.
And I'm Miranda Curtis.
All right, and
we're
we are doing the Math for Teachers 1 Summer 2020. So you guys, let's get started. Miranda, place the digits 8, 10, 11, 12, and 13 in the circles to make the sums across and vertically equal 31. Show all the possible combinations.
okay. So what we're going to do is we're gonna bring up our circles. Miss Dominique, will you click for me? Okay. Yeah, just keep clicking. Okay, so we're gonna do 12, 8, and 11, and that's gonna give us 31. Then we're gonna go 10, 8, and 13, and that'll give us 31. And how many combinations? That gives us 2. So we're gonna go to our next question. We'll just click along. Okay, Miss Dominique, look at the same diagram and fill in the missing numbers to numbers 1 through 4, questions 1B.
All right, here we go. So as you can see here at number 1, that we have 7, 8, 5, and 12, right? So 7 plus 5 gives us 12. 5 plus 12 gives us 17. 12 plus 8 gives us 20. And 8 plus 7 gives us 15. And there you have it right here. The next one will be, we have 7 plus 4 gives us 11. 4 plus 15 gives us 19. 15 plus 6 gives us 21. And 6 plus 7 gives us 13. The third one, well, as you can see, we really don't have anything that's going to equal the numbers here. So this will be a no solution. So our next one, we have 1 plus 8 equals 9. 8 plus 10 equals 18. 10 plus 6 equals 16. And 6 plus 1 equals 7. And here it is for you on the side to show you that it all equals what I just said. And so this was our simple diagram right here on the side to show us exactly how it should go. And I hope you guys got it. Miranda, sketch all the possible figures which can be formed and calculate the perimeter of each figures that can be formed.
Okay, so we're gonna go over here to our little help box that helps us determine our answer. So 9 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tiles along entire edge. See the 2 examples on the right. It'll pop up in just a second. The squares all have the length of 1. If you have little green squares, if you cut them out and you put them on a table, it'd be easy for you to have hands-on with it. But there's also our, just go click crazy. Our little squares right here, you could do that at home. It'll give you something to have in hand. Our squares right here are touching and we have 18. And then our next one, yeah, there's a lot of them. Make this one right here, and there's going to be another row right there coming up, and it's going to be 16, and then we have another one, and then we're going to keep going. I mean, you can make as many as you want. You can make as many possible sketches as you want, but regardless what you do, you're still going to get these 4 answers across the screen. Your littlest number is going to be 12, and you're going to make a square like this, and they're all touching. You're going to have ones all the way across. It's a little bit more. There's one more. I think there's 2 more. And then you have this, which is a zigzag, which is going to be 16 because you have one right there. And then you're gonna have this one right here is gonna be 14, and you just move one square down. And then you're gonna have this long one right here. It's just gonna be all squares. I should have just had those flying around. And this is gonna end up being 20. Now, when you do them all like this, make sure you count 1, 1, 1. And that's how you're gonna get your numbers. So click one more time for me, please. So in order, your possible parameters are going to be 12, 14, 16, 18, and 20. And then our next slide.
But you know what's so neat about this that you did? Like how you can take the first figure and make all these different type of squares to equal certain numbers. So that's really cool.
We'll see our next question is which figure has the least perimeter and which has the greatest. And that's always fun to figure out. I got them right there for you. They're going to pop up. I got pop crazy.
Right. So as we can see here, our least perimeter has 12. Okay. So that means our greatest one has to have, as we counting, 20. So the greatest one is 20 and our least is 12. So if you remember when Miranda just went back and did that and we seen all the numbers up here, this is where we got the numbers from. And that's how we figure out which one was the least and which one was the greatest. Miranda, the triangle numbers and the square numbers are shown below.
Okay, this is gonna be fun, all these dots. Okay, so right here in our demo, if you'll click again for me, right here you got 1, and then you come over here, and I put these shapes in so you can see your dots, and so it could be clean, because last time they weren't clean. And so we put 2 dots right here. I'm missing a dot, which will be 3, and then you're adding right here 6, and then your next one's gonna be 10, and then we're gonna come over here to our squares, and let's go 1, 3, there it is, 9, click again, 9, and 16. And see over here, you're gonna have Tn equals n inside n plus 1 over 2. And then our equation over here is gonna be Sn equals n squared. Okay, right here is our next question. It says, draw the next 2 figures to continue the sequence of dot patterns. Will you press it again for me, please, Ms. Dominique? Okay, we're gonna start with our help bubbles. One more time. Okay, there we go. Okay, so we're gonna do our steps because all this is confusing, I'm telling you. You gotta look right here. You look for the dot number patterns. Right here, we're gonna see it's 1, 3, 6, and 9. So when we come down here, we're gonna notice that we have 2 dots and then we have 6. So 2 minus 6 is 4. 6 minus 13 is 7. Click one more time for me. 13 minus 22 is 9. So we looked at the pattern between all of these, and our first one is 4, then it's 7, and then it's 9. And see the difference when you come down here to your next bubble, if you'll click again for me, so we can continue our pattern, is you come down, and the difference between these numbers is 3. And that's how you're gonna get your next number. Click again for me, please, Ms. Dominique. So we're gonna do that. So we'll have 2 plus 4 is 6, and then 6 plus 7, and then we have 9 next. That one is supposed to be a 13, and I know it's supposed to be a 13. And then we have right here, we're gonna do again, we're gonna plus, and it's gonna be 22, and then 34, and then 49. And see, if you come right here, that's how we're gonna get our dots. I was gonna do it different colors, but it was way more fun to make everything pink.
Right.
Okay, so we added to our sequence was 34 and 49. A list of the sequence of numbers that corresponds to sequence part A, and these are called pentagram all numbers. You can click one more time. So we looked at our sequence and it's 2, 6, 13. I know it's supposed to be 13. 22, 34, and 49. Ms. Dominique, will you click one more time for me? I should have not put so many transitions. Okay, Ms. Dominique, add 4 more equations to this list on the right. The equations are suggested by parts A and B. Question 3C through E.
As you hear, we got 1 equals 1, 1 plus 4 equals 5, 1 plus 4 plus 7 equals 12, 1 plus 4 plus 7 plus 10 equals 22. Our next one we have is 1 plus 4 plus 7 plus 10 plus 13 equals 35. 1 plus 4 plus 7 plus 10 plus 13 plus 16 equals 51. A lot of numbers, I know. 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 equals 70. And 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22 gives us 92. So next it says, observe that each pentagonal number is the sum of an arithmetic progression. Compute the 10th term in the arithmetic progression 1, 4, 7, and 10. So you have 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22 plus 25 plus 28 equals 145. Next, it says show the formula for the pentagonal numbers and calculate the 9th, 10th, and nth terms. So as you can see here, that, oh, hold on. Oh. Well, okay. So what we will use is AN equals AL plus D divided times 9 minus 1, N minus 1. And then you have 3N equals 31 plus 3 times N minus 1. So that's how you will do that. A whole lot.
No, you did.
Miranda, the figure to the right shows an addition pyramid in which each number is the sum of the 2 numbers immediately below. For each of the incomplete addition pyramids, show that the values in each square can be determined by forming and solving an equation in the unknown variable shown. Write an equation to solve each pyramid and show each step used to solve.
Okay, we're going to look at our little help bubbles before our stuff pops up. It says we need to look at where the exponent is to get our equation. So in our first equation, we're going to look over here where the x is. Okay, the exponent is in front of the number on the bottom, will be x to add. So we will do x plus 7. Okay, then we work on our next bubble. Next is working the squares. Add the bottom 2 numbers will give you the bottom, if you'll click again for me, please. Bottom on top of it and move on to other 2 sides. Add again to the next number. You know it is right when the 2 numbers under the top equal the top square. If you'll click for me again. Yeah, they'll start popping up.
See if you can do it on your end.
It's not letting me.
Okay.
Okay, there it goes. Okay, so as we said, we're gonna do x plus 7. So next we're gonna do 7 plus 3. We're gonna go side to side. It's gonna move up and our 10's gonna be here. And then we're gonna do, what is it? I don't know. Well, then we're gonna do 25 minus 10, which we're gonna do top minus the bottom is gonna give us 15, and it's gonna fill in our square beside our 10. And then we're gonna have 15 minus 7 gives us 8, which is gonna go here where the x is. X plus 7 equals 15, so we know it's correct. We checked ourselves, so x equals 8. And in our next square, we see right next to it, so it's going to be right beside it. So it's going to be 1 plus y because they're right here beside it. So 1 plus y. And then, yeah, it filled itself in over there. Yeah, just go click crazy. It won't matter. Okay, there it goes. So 1 plus y, because we did what it said in the help bubble, we did from the bottom. Then we're going to do the next two. So 8 minus 2 is 6. So it makes sense that 6 plus 2 equals 8. And then we have 1 plus 6 equals 7. And then we go right there, and 7 plus 8 equals 15, which is the top of our bubble. And then we have 7 minus 6 equals 1. So that means y has to be 6. Okay, let's go to our next one. Oh, I'm controlling. Oh, okay. Let's see. We're going to do this. Why did I do that? Okay. The figure to the right shows an additional pyramid in which each number is the sum of two numbers immediately below. For each of the incomplete addition squares, show that the value in each square can be determined by forming and writing an equation. Make sure you show your work. Okay, Miss Dominique, you got this, girl.
All right. So we have
Where'd it go? There it goes.
okay, so what we have here is z minus 2, okay, to solve this, and then you have 10, it's supposed to be 10 plus 17 will give you 27. 10 minus 2 equals 8. 8 plus 2 give you 10, which will be here. 8 plus 9 gives you 17, and well, z will equals 10. So 10 will go right here in our box. All right, Miranda, 4 married couples belong to a bridge club. The wives' name are Kitty, Sarah, Josie, and Ann. Their husbands' names, in some order, are David, Will, Gus, and Floyd. Use the table below to sort out who is married to whom.
Okay, so me and Miss Dominique gonna do this together. I'm gonna do half of it, and then it's gonna show the other half. Okay, so our little bubble's gonna come up. We have one more bubble that should be coming up that's gonna give us some inside info. Come on, little bubble. Okay, well, I got this bubble down here, so we good. Okay, so Floyd is Josie's brother. So there's no way they should be married. So we made sure that we are going to X them out. So we know Josie and Floyd. There's our X, Josie and Floyd. They ain't married. So then Josie and Gus dated some. But we know those two ain't together either. Because if we keep reading, it says Gus met his present wife after that. So we know they didn't marry. Well, he's not here. And so we have X there. Okay. And see, then right here, I know I went ahead and jumped right there, but it says Kitty is married to Will. So we know right there that Will and Kitty are married. So we know they ain't polygamy, so they can't go over to Sarah or Josie or Ann. So we know that's not happening. Okay, if we do one more click. Okay, Miss Dominique, it's your turn to take over it.
All right. So she said the same. So as we see here that David is not married to Kitty or Sarah. Will is married to Kitty, so that means David, Floyd, and Gus is not. Will is not married to Sarah, of course, or Josie. Floyd is not married to Kitty or Ann, and Gus is not married to Kitty, Sarah, or Josie. So that means Will is not married to Ann. David is not married to Ann. Floyd is not married to Josie. Floyd is married to Sarah. And Gus is married to Ann. So that leaves David married to Josie.
Yes, it does.
All right, Miranda, consider the trapezoidal numbers. 1 plus 1 plus 1, 1 plus 2 plus 2 plus 2 plus 1, 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. The nth trapezoidal number is 1 plus 2 plus on up, where n is a positive integer.
Okay, let's see. Okay, so it says create a dot pattern representation of the trapezoid number. So what we're going to do, 1 plus 1 plus 1 equals 3. So over here with our dots, we're going to put a dot above each number. So we have 1 dot above 1, 1 dot above 1, 1 dot above 1, which will give us 3. And then our next one, again, we're going to do the same thing. This is going to make it really easy if you put the dots above the number because it tells you how many dots you need. And then you don't have to be crazy like me the first time and guess because you get the number. So we have 1 plus 2 plus 2 plus 2 plus 1 is 8. And so we put our little dots above, okay? And then this one down here, it looks really scary. It's not. We got 1 plus 2 plus 3 plus 3 plus 2 plus 3 plus 2 plus 1 equals 15. And if you follow the dots, they will equal 15. Now, Miss Dominique, see, I put some pretty pictures in there for you. We're going to go to part B of this. It says, notice that 1 plus 1 plus 1 equals 1 times 3. And then we got 1 plus 2 plus 2 plus 2 plus 1 equals 2 times 4. And 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. Show how the dots in a representation of a trapezoidal number can be rearranged into a rectangle with 2 more column rows. You get it, girl.
So as you see, we have smiley faces. And we have 1 plus 1 plus 1 equals 1 times 3. So that gives you a star, and a star. Next, we have 1 plus 2 plus 2 plus 2 equals 2 times 4. As you see here, so that's 1, that's 2, 2, 2. So that's going to give you 4. Here's another one.
The transition was black.
Next, we have 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. 3 times 5. And there you have it. And there's another one that decided to join us.
They're special.
All righty. That's the end of our lesson. We hope you guys enjoyed. Thank you.
And we'll see you again for the next lesson.